So now for problem number 33, we're given cosecant of x. I apologize, the board is acting goofy. Cosecant of x is equal to 2. All right. And we're asked to solve the equation on the specified interval, which is from 0 to 2 pi. 2 pi. Now this one we can't use those fancy triangles because none of the triangles will equal to. Well, actually it might. Actually it might. I think maybe we could. I shouldn't speak. Usually we rig them up that way. So cosecant is the what? Reciprocal of sine. So what I could do is I can graph this. So really this is the same as saying 1 over sine of x is equal to 2. Now it doesn't specify how we solve. We could just do the inverse. That's one way to do it. You could just do it on your calculator. So one thing that you could do is well, there's lots of ways you could do that. I don't want to go too far astray from the book. Let's do it a couple of ways. The first way would be to graph the function 1 over sine of x. Now it's a reciprocal, it's not the inverse, so I don't want you guys to get confused. When we say sine raised to the -1, we're not talking about reciprocating. We're saying that's the inverse function, which is a different thing. That swaps the x and y's. We need to do this, and that's the left-hand side of the equal sign, and then on the right-hand side, we've got to have 2, right? So what I'm doing is I'm going to graph this as y1, and then I'm going to take and I'm going to graph this as y2. And then we're going to look for the intersection across the interval 0 to 2 pi. So to do that on my graphing calculator, I got to go to Window, and I'm going to go from 0 to 2 pi, and I could just hit, we know that it's 6.28, but I could just do it like this, and the calculator will do the work for me. What's the range on sine, cosine, all that stuff? Well, let's just leave it this way, and we'll go from there. So here's the graph. And it only intersects in 2 places, right here and right here. So I can use my calculator to graph that, and then I'll show you how to do it algebraically. So if I go to second trace, that gives me the calc menu, and I want to do intersect. And it says first curve, so I need to move this down around. Oh, I got to go all the way over here. All right, first curve, second curve, guess. And it's 0.52. 0.52. Now remember, that's probably it's pi divided by some number. Probably. Okay? So pi divided by some number is 0.52. So I'm going to write that down over here. X equals 0.52. And then I'm going to just guess and check. So if I come out of here and I say, I don't know, what do you think that is? It's pi divided by 6 maybe? That seems about right, right? Divided by 6 because it's 3, divided by 6 is about 5 maybe. I don't know, let's see. Divided by 6. Hey, I'm not too bad. All right, so that seems pretty good. Now let's try to find the other intersection. Boom, 0.52. Enter, enter, enter. And then 2.617. So over here we're going to say 2.617. And that'll probably be like pi over 6 times 5 or something. So now here's what I want to do. Remembering that sine is equal to the opposite over the hypotenuse. and I've got the number 2. I've probably got, remember that there is a 30, 60 triangle where this is 1, this is 2, and then this is the square root of 3. Well, we're saying that cosecant, which is the hypotenuse over the opposite, is equal to 2 over 1. Does that work? And this is a 30-degree angle, which is pi over 6 in radians. So if I switch my calculator to radian mode, now we got to remember that this is going from 0 to 2 pi. But it's a positive 2, not a negative 2. So if we were to think of this on this scale, I'm going to have one reference triangle here, one here, one here, and one here. All of these being pi over 6. But it has to be positive. Remember, we said that cosecant has to be positive, and that means it only occurs when sine is positive. And so what's the mnemonic device that Mr. Adams taught you guys to help you remember?
Smart.
Trig classes, right? So this is for all, this is for sine, and it's reciprocal, right? So this would be like cosecant as well. And then this would be tangent, and this would be cosine. So what quadrant does it live in? It doesn't live here. So it'd have to be quadrant 1 and 2. So I've got this angle here, which is pi over 6, right? And we said that before, right? X could be pi over 6. And then I've got the reference angle of pi over 6 here. But I've got to go from 0 to here, so it's what? If this is 0 and this is pi, what's this? Is that right?
How do you know it's gonna be 5 pi over 6 based on the decimal?
1 pi is the same as 6 pi over 6. 6 pi over 6 minus 1 pi over 6 is 5 pi over 6.
So you just kind of make the denominator.
I've had a little practice, so I do it a little quicker than you guys do. But yeah.
Okay.
Yeah. All right, you still go through there. And to be honest with you, it's almost like if I were to say to you, what's 3 plus 4? So you know that. So if you were to come to Mr. Adams and say, hey, what's 2 pi minus pi over 8? I would say 7 pi over 8. Right? Because I just kind of do it. It's a little different. You'll get there.
Okay.
You'll get there. But yeah, where this comes from is this over this, right? 6 minus 1 is 5.
So if the first, we got pi over 6, if it was pi over 4, and you're doing the same thing though, you just do 4 pi over 4, and that's subtraction.
Right.
Just make them the same. Okay.
Right. So so to help generalize that, make it a little easier, it's always going to come back to either 2 pi or pi because it always comes back to the x-axis. So you're going to either subtract or sometimes you'll add it to pi. Like if we were living right here, we'd say pi plus pi over 6. So you're always going to involve pi and 0 or 2 pi. Usually it's 2 pi.
Okay.
And that's how I've kind of memorized it, right? Because I'm always either subtracting pi over 3, pi over 4, or pi over 6 from pi, or I'm adding it. And so those numbers come up a lot. Okay? Great question, though.